guys, welcome to my channel Subhas classes. Today we are going for the part 2 of coordinate geometry, the 3-dimensional geometry meant for class 12. Since your exam is nearing, this video might be of a great help if you study with me 3-dimensional geometry. In this part, we are going to start with the angle between two lines, the angle between a plane and a line, angle between two planes. So for that we need to use the direction cosines or LMN and the direction ratios ABC. And if we try to revise a little from the previous class, we knew that the DCs of a line are LMN and the DRs are ABC. How are they linked? We know that L upon A is equal to M upon B is equal to N upon C, and you know that if square root of A square plus B square plus C square is taken as lambda or plus minus lambda, if plus minus of this becomes lambda, then you have as L square plus M square plus N square is equal to 1. So using these two, we can find L is equal to A upon lambda, M is equal to B upon lambda, and N is equal to C upon lambda. Means if we multiply lambda with the DCs, we get L lambda, M lambda and N lambda, then they are A, B, C. Direction ratios are actually the proportionate numbers with the DCs. If you have direction cosines like 1 by root 2, 1 by root 2 and 0, if someone asks you, are they DCs of a line? How to know? Since we have L square plus M square plus N square equal to 1, here this is L, this is M, this is N. You add the squares, 3 squares, and examine if the sum of the squares becomes 1. Put 1 by root 2 here, 1 by root 2 here and 0 there. Then you see this is 1 by 2 plus 1 by 2 plus 0, which is equal to 1. So these are true direction cosines of a line. And these two values, the two set of values L, M, N and the set of values A, B, C are linked with the number lambda. So if we know A, B, C, we can find L as A by lambda, M as B by lambda and N as C by lambda. And clearly you see L is to M is to N will be equal to A upon lambda is to B upon lambda is to C upon lambda, which is equal to A is to B is to C. So these are the whole number ratios of the values of LMN and they are linked with each other. So how to use them in our 3-dimensional geometry? When you have two lines, say this is a line, this is another line, this line is L1, this line is L2. These two have their direction cosines L1, M1, N1 and this has L2, M2, N2. Then these two lines are linked with an angle. If you extend, somewhere they meet each other and this angle theta can be found out from the formula cos theta is equal to product of sum of the direction cosines L1 L2 plus M1 M2 plus N1 N2. And if we put the values like L is equal to A by lambda type, M is equal to B by lambda and N is equal to C by lambda, then this becomes A1 by lambda 1 into A2 by lambda 2 plus B1 upon lambda 1 into B2 upon lambda 2 plus C1 by lambda 1 into C2 by lambda 2, which on further simplification gives you lambda 1 lambda 2 and here A1 A2 plus B1 B2 plus C1 C2. In a typical textbook of mathematics, you will find this formula written like this: cos theta is equal to a1 a2 plus b1 b2 plus c1 c2 divided by root over a1 square plus b1 square plus c1 square root over a2 square plus b2 square plus c2 square. And since we had earlier planned to write lambda for plus minus root over a square plus b square plus c square, so lambda has two variations here. This can be written as a1 a2 plus b1 b2 plus c1 c2 upon lambda 1 lambda 2 using this technique, so that we need not write long things and we do not feel bored at writing such long lines so many times. So now let us go to the next bit. What is the equation of a plane? Earlier in two-dimensional geometry, we know that the general equation of a straight line is ax plus by plus c is equal to 0, and this generally will be someone like this. This is line L, and for this line L, your slope is minus a upon b, and this can be put also in the form y is equal to mx plus c or mx plus b, where b is the y intercept and this is the x intercept. This was a precap. This is to make you remember that an equation of a straight line, which is a two-dimensional thing, a planar thing, looks like this. But what if we think of a plane, and if that plane is talked of in 3 dimensions, then the equation of a plane should be, this is the equation of a line, so equation of a plane will have an extra dimension, that is ax plus by plus cz plus d is equal to 0. Earlier we knew that slope m can be found from a upon b. So is there anything in 3-dimensional geometry? So what is that? If you drop a perpendicular here, say this is n1 into, then you know, according to a definition of a plane pi, if you draw a normal n1 n2, take any line on the plane, all lines would be perpendicular to this normal. So normal to a plane is normal to every line drawn on the plane. That is the definition of a plane. So how are these A, B, C, D related to this plane, the figure of a plane? For a figure of a plane, if this is the normal drawn, then the DCs of the DRs of this normal will be A, B, C, which are here. So that whenever you try to find the angle between a line and its normal, suppose I take a line like this, and this line has a DRS A, B, C. Since this line is the normal to the plane, so angle between this line and that line can be just the way we dealt now. Cos theta is equal to AA plus BB plus CC divided by root over a square plus b square plus c square for lambda 1 and root over small a square plus small b square plus small c square for lambda 2. So this will be the formula for the angle between a line and the normal to a plane. But this is not the angle between the line and a plane. If there is a plane like this and you have a normal here, and suppose you want to find the angle between a line and a plane. So since angle between a plane means angle that is there between, suppose I take a line here existing on the plane. So this line and this line have 90 degree between them, they are perpendicular. So this is not the angle between a plane and a line, this is the exact, it is already known, this is pi by 2. But when I have a line drawn parallel to the plane, suppose there is a plane like there is a line like this, I have a plane, I have a line passing through it, and I draw a normal here exactly at that point. Then my n1 n2 the normal and this line will make an angle theta, and this theta, for this theta this is true. So cos theta can be this angle, and if normal is drawn here, it is the same thing, normal is drawn here, the same thing, because for parallel lines the DRS are the same. So angle between a line and a plane can be found out from this formula. Next, how to find angle between two planes? You have seen laptops. When you open the laptop, you see a picture like this. So when you look at a laptop, the keyboard section and the monitor section have an angle, and if this is a plane pi 1, this is another plane pi 2, then what is this? This is the intersection of the two planes, pi 1 and pi 2 have been intersected here. So this is a line. So equation of a plane and equation of a line are in many ways linked with this concept. So when you have two different planes, each one can have a normal drawn. So if the normal drawn is here, which makes a 90 degree with this every line segment on this plane, and if you have a line segment here which is another normal, if this one is the normal n1, this is the normal n2, then angle between the two planes will be this and also this. So we can say angle between two planes pi 1 and pi 2 is the same as angle between the their normals n1 and n2. So since normal 1 has we can take two different formulae. Say pi 1 is represented by a1x plus b1y plus c1z plus d1 is equal to 0, and the second plane is given by a2x plus b2y plus c2z plus d2 is equal to 0. Then we get two sets of DRS. For n1 the DRS are a1 b1 c1, and for n2 the second normal the DRS are a2 b2 c2. So what will be the angle between the two normals? Now it is given by cos theta is equal to product of these three and sum. So a1 a2 plus b1 b2 plus c1 c2 divided by lambda 1 lambda 2, which are a1 square plus b1 square plus c1 square and root over a2 square plus b2 square plus c2 square. So this is the formula for the angle between two planes, which is given by cos theta is equal to this much. So you can take any two equations of two planes and use this formula to get cos theta, and if suppose cos theta becomes 1 by 2, then clearly theta will be cos inverse 1 by 2, which is 60 degree. So angle between the two will be 60 degree. So this is how we deal with the part 2 of three-dimensional geometry, where you can now go for the second exercise of the chapter and do a few problems from it. In the next class we are going to cover the next part of plane. So if you liked the video, go through it and have a subscription, and till we next go for the three-dimensional geometry, let us put a stop here. Thank you. Bye.